Good morning, students. Welcome for the next video. Hope you have seen the first two videos and understand the concept. As you know, in last video we have discussed about the Kepler's three laws and the Newton's universal law of gravitation. In the first video, we have discussed about concept of gravitation and the centripetal force. Now our next topic is to derive the centripetal force, magnitude of centripetal force, and proving that centripetal force is proportional to the square of the distance between the planet. So that is what we are going to our next topic. So first part we are getting, that is uniform circular motion and magnitude of centripetal force. So as in our first video of this chapter, we have discussed the uniform circular motion, or even you have studied in the ninth standard also. Now what is a circular motion? So when the object or any planet undergoes the circular path, that is what we say as a circular motion. And when it will be a uniform, so when the object covers a equal distance in equal interval of time in a circular path, then we say it is a uniform circular motion. Then as we again discussed in our first video, that is uniform circular motion is due to the centripetal force. The force which is responsible for that circular motion is the centripetal force. So just read what is given. As we discussed earlier, for an object to undergo circular motion, it is acted upon by a constant force directed towards the center of a circle, which is called the centripetal force. Okay, so here we have given this the definition of centripetal force. So I have just revised you the uniform circular motion. And now what is the centripetal force? So the when object undergoes circular motion, okay, whenever an object undergoes a circular motion, as you have studied again, it is going to be acted upon by a constant force. The motion is going to be taken place due to the force, as we have studied again in a first video. When a force is applied, then only the object will be set in a motion. Correct? The effects of force we have discussed. So whenever an object undergoes circular motion, that object is going to be acted by a constant force. And again, as we have discussed, whenever the object is in a circular motion, the force is always directed where? So it is always directed towards the center. And that is what the next line you are given. It is force directed towards the center of circle, which is called as a centripetal force. Is it clear? So understood the definition. So when an object undergoes circular motion, it is going to be acted by a constant force, and that constant force will be acting towards the center of circle, directed towards the center of circle, and that force is called as a centripetal force. Okay, and that centripetal force is going to be equal to, and this force is equal to F equals to mv square. Okay, what is the force is going to equal to? It is F equals to mv square. Now how this centripetal force F equals to mv square upon r? So that derivation we don't have. We have to consider only the centripetal force which is acting towards the center is equals to mv square upon r. How it is derived, that you will be studying in the higher standard. Okay, so right now you have to just remember that the centripetal force acting towards the center is equals to F equals to mv square upon r, where m is the mass of the object, v is the speed of object, and radius r is the radius of the circle. Okay, so which circle the object is moving, so that object mass we are going to consider, speed of the object, at what speed it is revolving, and the radius of the circle. Okay, so this is what just starting of the centripetal force. Now as we said, we are going to have the next part, that is derivation to show centripetal force is inversely proportional to the square of the distance. Now this force F equals to mv square upon r is going to be inversely proportional to the square of the distance. Means as we have discussed, if the distance is going to increase, the centripetal force will be decreasing, and if the distance is less, the sorry if the distance is going to decrease, distance of the planet from the sun is going to decrease, then the force of the centripetal force will be more. and if the distance is increasing, then the centripetal force is going to be less. Okay, so that derivation we are going to see. So let's move further. If a planet is revolving around the sun in a circular orbit in uniform circular motion, then the centripetal force acting on the planet towards the sun must be F equals to mv square upon r. Okay, so now suppose if you are going to consider this is a circular path. Here you are going to have a sun. Okay, and suppose the object is here. Now when this object is going to revolve in this circular path, okay, so the force will be acting towards the center, and that force is equals to how much? That is nothing but F is equals to mv square upon r, this force. I hope you are getting. Listen properly. So this is my sun. Okay, this is my sun, this is my planet. So when planet is going to revolve in a circular path around the sun, it is going to be acted by a centripetal force which is acting towards the center. You can see this F, and that F is equals to mv square upon r. Okay. Now here what is the m? So m is nothing but mass of a planet. Whatever the planet you are going to consider, that planet mass. V is the speed of the planet, by which speed the planet will be revolving around the sun, and r is the distance of planet from the sun. I hope you are getting. So the distance traveled by the planet in one revolution is equals to perimeter of the orbit, and that is nothing but 2 pi r. Now when the planet is here, when it's going to complete one revolution around the sun, so one revolution around the sun is nothing but what? It is a perimeter of orbit. And what is the perimeter of orbit? Orbit is our circular part, correct? And as you know, the circumference of the circle, that is nothing but the perimeter of circle, which is equals to 2 pi r, and therefore you are getting perimeter of the orbit is going to be 2 pi r. Means when a planet will complete one revolution around the sun, its distance cover is going to be 2 pi r. Is it clear? Next part we are having time taken is equals to period of revolution. Now we know that what is period of revolution. So time taken by a planet to complete one round around the sun, that is what we say as a period of revolution, and therefore time taken to complete one round is nothing but a period of revolution that we consider as a capital T. So now, as you know the formula speed, whenever we want to find the speed, what is the formula of speed? That is distance travel upon time taken. What is the distance travel? Now when the planet completes one round around the sun, means the distance travel is nothing but 2 pi r, and how much time is taken to complete that round? It's a period of revolution, that is capital T. I hope you are clear. So F is equals to mv square upon r. Our first formula again, we are coming to the centripetal force, because now we want to prove centripetal force is proportional to square of the distance. So we have to come back to our centripetal force formula. This formula we are going to consider now. Okay, F is equals to mv square upon r, which is equals to m upon r will be as it is. Now this v square, what is v? So the speed v is equals to 2 pi r upon t. Therefore instead of this v, we are going to write 2 pi r upon t, the whole square, the bracket the square, because it's a v square. Getting? So is equals to, what is 2 square? That is 4. This m will be as it is. What is pi square? So pi square, and r square is a r square upon this r, and this t is divided, so that will come in the numerator, so therefore it is a t square. So it is 4m pi square r square upon r t square. So it's the same step, only nothing but we have made a square of this part. This part we are going to make a square. Okay. I hope you have understood. So it becomes 4m pi square r upon t square. Now here it was r square, now it become ry. So from here square and here r get cancelled. Understood? So these two will get cancelled and only one r will remain. And from the denominator, one r get cancelled. So it becomes 4m pi square r upon t square. All are here up to with me, all up to this, all with me, na? Understood? If you are not understanding, just listen once again the video. So multiplying and dividing by r square we get now this above equation, this equation f is equals to 4m pi square r upon t square. We are going to multiply and divide by r square, means numerator and denominator both will be multiplied by the r square. So f is equals to 4m pi square r upon t square. This part as it is, we have took 4m pi square r upon t square multiplied by r square and divided by r square. So what you will be getting, 4m pi square r into r square. This r into r square become r cube, and this r square will be as it is, so r square upon t square. Okay, now here only I have made the interchanging the places are interchanged. The t square is in the first fraction, that comes in the second fraction, and r square in the second fraction goes in the first fraction, means the denominators are only exchange. In the numerator r into r square becomes r cube. Why I did this? Because according to the Kepler's third law, what the Kepler's third law says, that t square upon r cube is equals to k. This law, as we have studied in the last video, third law says that t square upon r cube is equals to k. So now this part you are going to replace here, r cube upon t square. Okay, so you are going to replace that part in the next step. So you can see for f is equals to, I will remove this, so you will not have problem. F equals to 4m pi square upon r square upon k. Now why r from where you get the k? So this part will be now as it is, 4m pi square upon r square as it is, and instead of this r cube upon t square, according to Kepler's law we are getting k, and therefore it is written 1 upon k, because reciprocal na, t square upon r cube is k, so r cube upon t square will be 1 upon k, so therefore it is 1 upon k, so k comes in the denominator. But 4m pi square and k, now in this formula, these 4 m and pi square and k, these all are constants, so what is only changing, that is the r square. Okay, and therefore we say f is proportional to 1 upon r square, and that is what we have to prove. That is what we have said the topic, no, we have to prove that f is proportional to 1 upon r square. I hope you have understood the concept. Thus, we can conclude, Newton concluded that the centripetal force, which is the force acting on the planet and is responsible for its circular motion, must be inversely proportional to the square of the distance between the planet and the sun. Okay, and therefore from this whole derivation Newton have concluded that the centripetal force which is acting between the planet and the sun, which is responsible for the circular motion of the planet, that force is inversely proportional to the distance of the planet and the sun. Means, as I said at the start, if the distance is more, centripetal force is less, and if the distance between planet and the sun is less, force will be more. I hope you have understood the derivation. If not, listen the video properly with the step by step, and even if that you are going to have any doubt, you can write me in the comment or contact me. Okay, this concept is called as a inverse law. So you may get a question, derive the inverse law, so it's nothing but the same thing, this derivation only, or you can say get a question derived, show that the centripetal force is inversely proportional to the square of the distance. Again the derivation is the same, so understand and remember, practice the derivation at a home. Now our next topic, that is the high tides and the low tides in the sea. We know that we use, everyone like to go and visit the sea during the weekends or the holiday times, and whenever we go to the sea we can see high tides and the low tides. So how that high tides and low tides are taking place, how it is happening, that is what we are going to see. So the level of sea water at any given location along seashore increases and decreases twice a day at regular intervals, due to which we can see regular occurrence of high and the low tides at different times at different places in the sea. Now we know that what is high tide and low tide. So high tides and low tide is nothing but the increasing the level of the water at particular place, particular location. There is a increase in the level of water. At the same time, on the opposite side, at a 90-degree angle side, the level of the water is going to decrease, and wherever the water level is more, there we are going to call it as a high tide, and where there is a level of the water is less, there we are going to call it as a low tides. Okay, and it is going to take place on a regular intervals, twice in a day. Okay, two times it's going to take in a place in a day. Okay, and it is going to be at a different times in a different places. So how it is happening, and why these low tides and the high tides are taking place, why and how these high and low tides occurs in the sea. So it is because the position of the moon and the earth, it is depend, the high tides and low tides are depend on the position of the moon and the earth. Okay, so the level of water in the sea changes because of the gravitational force exerted by the moon. Okay, so why this level of water increase or decrease in the level of water is taking place, it is because of the gravitational force of the moon. So water directly under the moon gets pulled towards the moon, and the level of water there goes up, causing high tide at that place. So whenever the moon is going to be at particular place, so due to its gravitational force, the water will be pulled towards the moon, and because of that, what happened? The water level increases, and that is what we call as a high tide. Now, when the moon is going to pull the water, from where they will getting the water? It's going to pour something extra and pulling? No. So from other sides the water will be pulled out, and therefore on the opposite side, as I told, at the two places on the earth at 90-degree from the place of high tide, wherever the high tide will be taking place, at the 90-degree from that place, there will be less amount of water, means water will become minimum, level of water is minimum, and low tide occurs there, and that is going to take a low tides. Just see the figure, then we'll understood. See, this is the same picture you're having in the textbook. You can see this is the moon, this is my moon, correct, and this is my earth, and this the blue color circle which you can see, that is my water. Now when my moon is here, it is going to pull the water towards it, gravitation pull. Gravitational force will be attracted by the moon, and therefore water is going to pull towards the moon. So this area here you are getting now more water. Now from where this water is pulled up? From here, correct, from this part and this part, 90-degree, correct, the water is pulled, and here the water level has increased, and therefore this part as well as this part, so on both the opposite sides there will be a high tides. And at a 90-degree, this place is here, so 90-degree with this place is what? This is my 90-degree, correct. So at this place and this place here also 90-degree I will be having, no? So on both the side 90 degrees there will be a low tide. Is it clear? Means similarly, when this moon suppose comes here at this position now, when the moon will be here, what happens? The water will be pulled up here. One minute. Suppose now instead of the moon, moon is here now. At this position, the moon will be now. So what happens? Water will be pulled up. Correct? Am I right getting? Water will be pulled up. So this side and this side, above and down, the water level will be increasing, and left and right the water will be decreasing. So up, above and down, there will be up and down, there will be high tides, and the left and right there will be a low tides when the moon is on the top of the earth. Is it clear? Again, when the moon will be on the left side, what happens? Same thing what you have seen in the picture. Again, when the moon will be at the bottom here, you can see the high tides in the above and down, and left and right again there will be a low tides. I hope you have understood. If not, just go through the passage properly, and to understand it more clearly, you can visit these two links. of the YouTube. Visit these links and see the videos there, so you will get a clear idea how the high tides and low tides are taking place. And with this, we have finished the two concepts here. Go through the video properly and study it properly. Thank you.